Hi everyone, this is Mike from Cleveland Aircraft Tool here, and welcome to our new streaming format. I hope you bear with me as I learn how to use the software a little bit. I've been practicing, but you know how that goes when it's live. So we'll give this a shot. Tonight we're going to talk about squeezer yokes and where they are different yokes, different shape yokes are used. So first of all, in the right side of your screen here, you'll see a chat window, a comment box, and I see a few of you have already used that to start typing in some questions, and we want to encourage you to do that sooner rather than later. Don't wait till I ask for questions to type them in, because although we are live, there's about a 20-second buffer with this streaming format, so we'll have 30 seconds of space if you wait till I ask for questions before you see that and type your question back in, and then I start answering the question again. So anyway, go ahead and do that. Anytime you come up with a question, whether it's a yoke question or not, I'd appreciate that. The Google Hangouts were great because we could go back and forth really quickly with questions, but we're trying to have a better quality stream so you can see a little more detail on what we're talking about. So hopefully this will work out, and as always we want to hear your feedback from it. So let's see, let me look at my notes here, sorry. And I think I mentioned questions don't have to be about squeezer yokes. You can ask questions about anything you want, and I see that one person has already done that, and that's great. We'll take care of those at the end. So let's get right into it. There's three basic styles of yokes. There's what's called the C yoke in the upper portion of this picture. There's the longeron yoke, or the flange nose yoke, down below it. And then off to the side there's the thin nose yoke. So those are the three basic styles. And then each style, there are several different lengths of yoke, or reaches, sometimes they're referred to. So the top one you see in this photo is a 2-inch yoke, and then there's a 2.5, a 3-inch, and a 4-inch yoke. So there's various depths. The trade-offs, when going to a longer yoke, you can obviously reach more rivets, but the weight and the flex of the yoke become a factor. So we think the 3-inch yoke is a really good yoke for all-around use. And then we look at the others, the non-3-inch reach, as more specialty yokes for different situations you find yourself in. Let's see. So let's go to the next picture here. This is the 3-inch yoke on a squeezer, doing a general squeezing operation. So this is what you would expect to see as you're doing some sub-assemblies or something like that. So the 3-inch gives you a good reach. It's a reasonable weight, and it's still rigid enough to set 1/8-inch rivets that are fairly long. So the 3-inch yoke is what we use if you're going to only have one yoke. Okay, the next one here, I have a picture of the same 3-inch yoke trying to get a nut plate in an inspection panel. Now this nut plate probably should have been done when the skin was off on the bench, but you know how that goes. So this one won't quite get into this application, and this is the place where you would go to a 2-inch yoke, where it could fit through and not be obstructed by the back end of the yoke. Now the next picture I have here is a 3-inch yoke reaching in from an end, kind of simulated. I have a little piece here that I use for demonstrating a lot of different things, and so what I've done is I've reached in from the end to simulate squeezing these nut plates, rivets. And this 3-inch yoke can get one side of the nut plate rivet, but it can't get the other side. So that's where you could use a 4-inch yoke here, and that would give you the additional reach to get that one extra rivet. Now, I don't typically recommend the 4-inch yokes because they are more flexible, and especially with 1/8-inch rivets, they spring a lot, which can lead to rivets sliding over sideways, and so you want to be careful with that. Again, you can reach 1 inch further, but most of the rivets in the airplane are done with rivet gun and bucking bar anyway. So for this particular application, I would save the $140 and pull out the bucking bar to do it. But it is an option for those that want to squeeze as much as possible. That leads me into the thin nose yokes. The thin nose yokes are, well, sorry, let me back up. The thin nose yokes do not have a hole in the top of them, for those of you who aren't familiar with thin nose yokes. You're actually setting the rivet up against the top of the yoke. And that means that you can't use them with dimple dies. They're only for squeezing rivets, and that obviously makes the yoke a very limited use. Here I just have an example of flanges being dimpled with a regular yoke for beginners to start thinking about if they're not into a project yet. The half of the airplane is dimpled with the squeezer. That's mainly what you use a rivet squeezer for, even though it's called a rivet squeezer. You primarily use it for dimpling. And so you need a yoke that's able to accept dimple die in the top of the yoke. And that way you can go along and squeeze all those rivets, all those dimples in all of the flanges of all of the substructure, which is about half the dimples on the airplane. Bear with me a second here. Okay, now I have a picture of the 3-inch yoke trying to squeeze a dimple, or a rivet, I guess, in the trailing edge of a control surface. That's where you use the thin nose yoke most of the time, because the 3-inch yoke with a set in the end of there can't get in there. The set, since it's not a no-hole yoke or a thin nose yoke, you have to have the set in there to squeeze up against. So that adds some thickness there. And that's when you end up needing the thin nose yoke. So this is a 3-inch yoke with a set. And then this is the same rib with the thin nose yoke. So you can reach in there and get 2 more probably rivets on each control surface rib that you can't get with the standard yoke. And then this is a picture that I just stacked up. It's kind of hard to explain this on the phone sometimes, but I stacked up the nose, lined up the nose of each of the 3 thin nose yokes, so that you can see that the nose profile is exactly the same, independent of the reach. With it's about 1/4 of an inch thick space that you have to have. So if you're out in the open and you don't have a space restriction on the back side, you can use any of the 3 of these and they work equally as well. The reason I bring that up is because a lot of the RV8 guys use the 4-inch thin nose yoke if they're going to buy a thin nose yoke, because they have a whole row of rivets that the 3-inch won't quite do, but you can squeeze the rivets with a 4-inch thin nose, and so then they have the thin nose yoke plus the extra reach. So that's a pretty popular combination. Let me go to the next slide here. Now this is the 1-inch thin nose yoke, and I really like the 1-inch thin nose yoke to be able to reach inside inspection plates and get those, or get the nut plates for inspection panels and areas like that. It's very, very light, it's very, very rigid, and you can get into really tight places like this through little holes. So when you're setting rivets up against the edge of a sheet, they work really well. The next one is the flange nose yoke, sometimes called the longeron yoke. And the purpose of this yoke is to come back down with the yoke to reach over an edge. So when you're riveting over an angle and setting a rivet on the back side, you can reach over the edge and you can set that rivet really easily with the longeron yoke. Here's another picture I have of, I believe this is a floor rib, probably where the floorboards attach. And you can reach over that flange and you can get that rivet where it rivets the angle to the rib itself. Oh, the longeron yoke is so handy that you probably will find yourself, if you have that yoke as a specialty yoke, you'll probably find yourself leaving that on the squeezer about half the time. You put it on there to do some application, and rather than switching yokes back, you just kind of leave it on. But because of the thickness, let me go back to another shot here. Because of the thickness of the top of the yoke, really is a space restriction in some cases, and that's why I don't recommend it for just a standard yoke. but it works pretty well for reaching over things. When you're building up the rear spar of the horizontal stabilizer or vertical stabilizer, there's flanges there that you can reach over with that. So it becomes pretty handy there. So obviously the price per rivet comes up on the specialty yokes because you may get a thin nose yoke that you're only squeeze a dozen rivets with. So the cost does go up, but sometimes there's only a few ways that you can get in there. Otherwise you use a pull rivet, and it seems like nobody wants to do that. So let me go and see if there's any questions. Quite a few questions here. Let me start at the top, and I'm going to skip the non-yoke questions. The smaller throat on the thin nose yoke, does the concern about flex go away? Yes, the longer you get on the throat, the more flex you get. So like I said, the 4-inch is almost unusable in my opinion because of the flex, especially on 1/8 inch rivets, where it wants to just fold the rivets over. The smaller the yoke, the more rigid it gets, and the easier the rivets set even with them. Now I see from Bill says, can you show us how to change a yoke? So I'll go to that here. This is on our hand squeezer. It's the same as pneumatic. Sometimes other companies use bolts, but there's two 3/16 cylindrical fasteners that hold the yoke on. You just pull those out. You pull the yoke off the top, pick your other yoke, put it on there, and then just pop the pins back in. Again, you might have bolts with nuts on the back side, but the concept is the same. Not to use adjustable. Is the adjustable set holder? Is that what you're talking about there? The part that the dimple eye sits in. Yeah, that's called an adjustable set holder. I don't have a very good camera for details. We're going to get that fixed here in the next one, but this piece here rotates in our squeezer and adjusts up and down. And that, yeah, don't use it with the pneumatic. It's the same thing. The adjustable for the pneumatic is the same thing. In fact, in ours, it's the same top part. It's a different bottom part that sits in your pneumatic squeezer. So there's some, I would call it misinformation out there about the adjustable set holder on pneumatic squeezers. And what that is specifically is I think you can see it on this one. Give me just a second here. We make our adjustable set holder for the pneumatic squeezer with 1 1/4 inch long thread in it, which is a 5/16. I say that, but this is not it. Let me see if it'll focus on it. Of course not. Well, you see the male thread there. That's about 1 inch long. This is a year 2000 model of the main squeeze. So it's an older version. But what we do in the pneumatic squeezer and the adjustable set holder is we make this female thread 1 1/4 inch long, which is very, very difficult to do machining wise. And it's a 32 pitch thread. The reason those two things are important is because when you get into the longer yokes, and this is where the misinformation comes from, is the longer yokes have a deeper base on the bottom, and that's so that they're more rigid because of the flex. So with this deeper base, it means that you have to extend it out further. I don't know of anybody else's adjustable set holder on the market that will work with this yoke, but ours does. And the reason is because we make these 1 1/4 inch long, where it's easier to make them 1 inch long. So what happens is when you put this yoke on, and especially this yoke where you're setting the rivet right up against the top here, you have to crank the squeezer or crank the set holder up to meet that gap. And so you're getting out on the very ends of the threads with all the other guys' set holders that will just crush the threads off the end of them. Ours being 1/4 inch longer, you can still use the adjustable set. You can still use our adjustable set holder with our 4-inch yokes. I should clarify that in case there's other yokes out there that it doesn't work with. But yeah, that's why we've done that, is so you can still use the adjustable set holder. Works very, very well, and the beauty of the adjustable set holder on hand squeezer, pneumatic squeezer, anything, is you're often going along a row of rivets squeezing them, and you get to a cross piece or something where there's an extra thickness of metal or a J channel or something else in there. So you have to go to a next dash length rivet. Well, with our adjustable set holder, ours is also the only one with 32 threads per inch, which is what rivets come in, is 32nd of an inch. So if you go from a dash 3.5 to a dash 4 length rivet, it's just one half turn in to change that rivet, and then you do that rivet and then you go half turn back out and you keep going along your line. So it's very, very handy. Or I think almost all of them you find, other than Cleveland's, are 24 pitch thread in there, and so then you have to do a mathematical calculation on how many partial rotations that is to make it exactly right. So makes it really easy to go back and forth on different lengths of rivets, and our adjustable set holder for our pneumatic squeezer does work with all of our yokes, including the 4-inch. But that's where the misinformation comes in, is it's with that thicker base on the yoke. With the fixed set holders, we do make or the manufacturer makes a set holder for the one yoke and then a longer set holder for the other yoke, which you can do that, but then you have to shim them up with washers, and it just takes all the fun out of building. What percentage of rivets would the squeeze box be used? You can use the squeeze box or the pneumatic squeezer on any rivet that you can use a hand squeezer on. Hand squeezer, pneumatic squeezer, squeeze box, they'll all be exactly interchangeable because they all use the same yoke. The yoke is really what regulates where you can get it in and not. Because of the length of the handles, I mean, it's possible there's an obstruction because of the length of the handles, where the pneumatic squeezer would be slightly shorter and then the squeeze box would be drastically shorter. But it's really just an ergonomic thing. While we're talking about squeezers, the disadvantage of the hand squeezer, and that's anybody's hand squeezer, is that your force is 12 to 14 inches away from the rivet, and so everything is hard to keep square. With the pneumatic squeezer, you're right up against it, and then you have the other hand to operate the pneumatic portion of the squeezer. With the squeeze box, it's the same thing, you just don't have the mass of the pneumatic squeezer. It's, I don't remember the weight now, 2 pounds or something like that, so it's just very, very lightweight and ergonomic, easy to use. But space restrictions, really not much of an issue with those. All right, well, thanks for watching, and send me email at mike.toolman@gmail.com. Visit our website at clevelandtool.com, and give me any tips on what you want to see for our next hangout.